We will now begin part 2 of the beginner course on the fundamentals of noise. First, I will explain the types of noise. Noise is an unintended component contained in voltage, current, signal, and so on. When the output voltage of a regulated DC power supply is magnified, it contains an AC component due to the switching frequency. Such unintended components are called noise. There are two main types of noise sources: natural noise and artificial noise. Natural noise includes lightning strikes and static electricity, while artificial noise comes from familiar sources such as industrial equipment and fluorescent lights. There are also three main noise transmission paths. Conduction noise indicates noise generated by an inverter or power supply that is transmitted to wires or patterns. Inductive noise is noise that is induced and transmitted by electromagnetic induction or electrostatic induction when power or signal lines of peripheral devices approach a line where noise current is flowing. Radiated noise refers to noise generated by inverters and power supplies that is radiated through input and output lines as antennas and transmitted to processing equipment. Let's now talk about noise test EMC. EMC stands for electromagnetic compatibility, which means that the product has both the capability to suppress EMI, or noise, generated by the equipment and to withstand EMS, or noise, from other equipment. Our EMI-EMC filters are parts that counter EMI and EMC. Next, I'll describe the types and effects of conduction noise. Conduction noise can be divided into two types: differential mode noise and common mode noise. Differential mode noise, also called normal mode noise, refers to the noise that occurs between the power lines connecting the input and the equipment, and common mode noise is the noise that occurs between the power lines, which connects the input and the equipment, and the ground line. Differential mode noise is characterized by noise currents flowing in opposite directions to and from the line, and noise current loops are small and electromagnetic radiation tends to be small. Common mode noise currents are characterized by currents flowing in the same direction between lines. Because the overall noise current loop of the device tends to be larger and the electromagnetic radiation tends to be greater, the malfunctions that commonly occur are often caused by impact from common mode noise. Conduction noise generated from switch mode power supplies can be divided into two types: conducted noise voltage leaking to the input side and output noise leaking to the output side. Conducted noise voltage and output noise include differential mode noise and common mode noise, which are generated from switching FETs, transistors, diodes, and transformers inside the power supply. Finally, we will use the onboard power supply as an example to describe radiated noise transmitted through atmosphere, such as magnetic fields, electrolysis, and radio waves. First, let's look at transmission by magnetic fields. Magnetic field noise is mainly generated from transformers and chokes synchronized with the switching frequency. In some cases, it directly affects ICs or electromagnetic coupling with control circuits, resulting in noise, which in turn affects ICs. In the case of open-type power supplies, there are cases where the magnetic flux generated by transformers and chokes coupled with the surrounding circuits, resulting in noise. Next, I'll explain transmission by electric field. Electric field noise is generated by switching elements and circuit patterns with high voltage amplitudes. The switching operating voltage of a DC-DC converter with a 24 VDC input is approximately 70 volts. Electric field noise is transmitted by the return of the capacitance between the noise source and the control circuit. This concludes the second part of the fundamentals of noise for beginners. Thank you for watching.